The production of distilled spirits is an energy-intensive process which traditionally uses fossil fuel-derived thermal energy in brewing and distillation. The greenhouse gases produced contribute to Scope 1 emissions. Scope 3 emissions are associated with cereals as greenhouse gases are emitted during the cultivation, processing, and transportation of cereals. Anaerobic digestion can convert byproducts, including draff, thick stillage, and thin stillage into biogas, which can replace fossil fuels and reduce Scope 1 emissions. Digestate can be used as a fertilizer in cereal cultivation and reduce Scope 3 emissions. These byproducts are currently dried to produce high-protein animal feed, and if used in digestion, this would reduce energy consumption of the distillery as drying would no longer be needed. However, a drawback is the reduction in animal feed and requirement for replacement animal feeds, which would result in additional greenhouse gas emissions. This work balances the benefits and drawbacks of digestion of byproducts using compromise programming. From 9,261 scenarios, the combination of byproducts to use in digestion selected based on criteria chosen by management of a large distillery was 100% of draff and thick stillage, with no thin stillage. This could replace 48% of natural gas consumption at the distillery, reduce Scope 1 emissions by 45%, achieve a Scope 3 emission savings of 22% of current Scope 1 emissions, and reduce electricity consumption in the feed processing plant of the distillery by 63%. Protein loss of 9,618 tons could require the import of 19.59 kilotons of distiller grains and 9.15 kilotons of soybean meal. This paper was published in the Biofuel Research Journal's September 2021 issue, and we would like to invite you to read the full paper for free on Journal's website at www.biofueljournal.com.